Welcome all. In this session, I'll take around 15 to 20 minutes, not more than that. There are some inconsistencies with respect to Kutzbach equation. Let me show you, or Grubler's equation, the degree of freedom is given by, we study in theory of motions, the degree of freedom is given by 3 into n minus 1 minus 2 number of sliding pairs, number of turning pairs, and number of pairs with pure rolling minus number of higher pairs, and this is Kutzbach equation. And I have derived this equation in my plus class. Okay, next. So as per, if there are no higher pairs, the equation becomes 3 into n minus 1, 2 times sliding pairs plus turning pairs. There are no higher pairs. This is my Grubler's equation. Okay. Now, my dear students, this equation, the derivation of degree of freedom, we just take number of links and how many motions are arrested and how many motions are available and what type of pairs are those, like binary, then we'll have like sliding pairs or turning pairs or pure rolling or like higher pairs. Higher pairs means roll with slide. Only that. Other than that, we don't take geometry, anything, shape of the link, size of the link, we don't take into account. Okay, sirs. Now, let's see some of the inconsistencies. Okay, let us take this figure. Now, if you observe clearly, this is a fixed link. So, let us take this red one as link 1. Let us take red one as link 1. All fixed links. What is the definition of link? Link is that which permits relative motion or guides the other element or other member. Okay. But here fixed is link 1. The green one is link 2 and this white one is link 3. So total number of links are 3. Okay, sirs. Now, between 1 and 2 there is a sliding pair. So one sliding pair. Between 1 and 3 there is sliding pair, 2 sliding pairs. Between 2 and 3 there is a sliding pair. I repeat, sirs. 1, 2 is sliding pair. Between 1 and 2 there is a sliding pair. Okay. Don't count this as 1, this as 2. No, it's a complete system. This is a link 1 and in that link it is sliding. So this is link 1, this is link 2, there is a sliding pair. And 2 and 3 there is a sliding pair. Okay. And 3 and 1, this is 3 and 1, there is a sliding pair. Okay. So total number of sliding pairs are, if I write, number of sliding pairs is 3. Okay. Now there are no higher pairs. So there are no pairs with pure rolling. So therefore my equation becomes, my dear students, now apply. The degree of freedom is given by 3 into number of links are 3, n minus 1 minus 2 times sliding pairs are 3, no turning pairs, no pure rolling, no higher pairs. So this equation 3 minus 1 is 2, 6 minus 6 is 0. So this equation will give me the degree of freedom 0. What does it mean? It's a structure. Means there is no relative motion between elements or links. So this should not move. But actually if you observe, if I give some input, say have pushed this link 2 from the left, definitely this will move up. Means there is a 1-to-1 correspondence. So the degree of freedom is 1. It is a constrained mechanism. So there is a clarity. If I give one input, there is one output. So definitely if I push this motion to horizontal, there is a motion. So therefore there is something wrong with this equation. Now can I say this equation is wrong? The answer is no. The problem with this equation is it has not taken geometry, shape of links into account. It has simply taken into account number of links, number of pairs. That's it. The geometry, the size, nothing is taken. How the motion is taking place, that it is not taking. So then the explanation given to this is something like this. What explanation, probable explanation can we give? So does it mean, but some textbooks say there are 3 sliding pairs. Yes, it is a mechanism. So therefore 1, 2, 3. Now the explanation says if three sliding pairs are in a loop, from your side you add one. Books say like this, but I'm not convinced with that answer. Why do we need to add that? But what I personally feel is some changes must be made. So therefore, the correct explanation given is like this. Don't change anything. Now, the correct explanation is definitely there is a degree of freedom. Here it has a degree of freedom of one, undoubtedly. Because if you are giving one input, you are getting exact output. अगर इसको मैं कुछ x distance move करता हूँ, exactly corresponding to that x, there is one-to-one correspondence. उतना ही output आएगा. So definitely the degree of freedom is one. So in this it is sliding. So yahan slide from here it slides and moves up. So the degree of freedom must be one. So how do we explain this? Dekho. Now the explanation is something like this, my dear students. Let us take this link 3 and this is link 2. Link 2. Yes, this is link 2. Now this is, one second please. These are very, very important, my dear students, from interview as well as from examination point of view. This is a fixed link. Okay. Now we have white link. This white link. Okay. Now. Oh ho ho ho. Isko thoda aisa. We'll remove this and we'll introduce something like this. Okay. Now this is all one link. It's the fixed one. So now you may be wondering, sir, it is the same now. Dekho, look at the explanation given to this is whenever without changing the nature of motion. What is the motion? The x input is resulting in y output. Without changing the nature of motion, if the lower pair, yes, 2, 3 is a lower pair. If a lower pair is replaced with higher pair, for example, what I do is, now I'll keep like this. This is complete one link. Please note on this white one. There is no relative motion between the circle and this rectangle. This is complete one link. There is no relative motion between this and this. This is complete one link. So link 1, link 2. This is link 1. Okay, sorry. This is fixed. So एक ही link होगा. This is completely fixed. This is completely fixed. So it will be link 1 only. Yes, complete fixed is link 1 only, and this is link 2 and this is link 3. Yes, very good. Ab dekho sir, just because the geometry of the link is not taken in Kutzbach equation, that's why there is a correction. So don't think that it is wrong. Therefore, now alright, the number of links are 3. 1, 2, 3. Yes. Now how many sliding pairs are there? Between 1 and 3, there is one sliding. Between 1 and 2, there is sliding. Between 1 and 3, there is sliding. So therefore, there are 2 sliding pairs. Now, look at between 1 and 2, there is sliding. Between 1 and 3, there is sliding. What about 2 and 3? 2 and 3 constitutes an higher pair. 2 and 3, there is a point contact. It is a higher pair. Now, let us calculate the degree of freedom. 3 into n minus 1 minus 2j minus higher pair is 1. So this is 6. 2, 6 minus 4 minus 1. Yes, it is 1. Absolutely. So the explanation given to this is whenever the lower pair is replaced with a higher pair without changing the motion, you have to use higher pairs. That is the explanation. So the reason here is why do you give the what is the reason for this inconsistency? Because this Kutzbach equation or Grubler's equation, they have not taken the geometry of the link into account. मतलब simply they said sliding, that's all. तो इसलिए मैं सिर्फ geometry shape को change किया, तो you got the correct one. This is the correction. Hope you understood. Yes. Now you can explain. If I give one input, it is resulting in one output. Very good. Now let us see. One more, there are many inconsistencies, so we have to be very, very cautious. For example, let us take Yeah, before this, I'll take this. कुछ इसके साथ explain करूंगा sir. I'll explain with this. Okay, fine, no problem. What I do is, my dear students, let us take, इसको निकाल देंगे sir. 1 second. So we are enjoying Tom in class with all models plus classes. So I thought कि okay, now देखो. 1 second please. Just give me 1 minute. हाँ, हो गया sir. Yeah. अब देखिए. I have 5 links. 1, 2, 3, 4 filings. I'll show you like this. This is the one. देखो, मैं आपको यही फिगर शो करूंगा सर. Yes, something like this. देखो, something like this. ठीक है. This is okay. All are pin joints. All are pin joints. All are pin joints. Let us take इसको फिक्स करेंगे. Actually, it is like this. सर, ये पूरा एक ही लिंक है सर. This is a single link. ठीक है, this is a single link. देखो, this is all single link. Whenever on a single link is connected, we'll show like this. ठीक है. Let this be fixed. This is link 1. This is link 2. This is link 3. This is link 4. And this is link 5. ठीक है, sir. Now understand carefully. So number of links are 5. Let's see number of joints. Joints देखेंगे, sir. Binary joints. Let's see. 1, 2, 3, 4, 5, 6. Okay. Number of joints are 6. These are all turning pairs. Okay. 6. देखो 1, 2, 3, 4, 5, 6. Applying the equation. There are no higher pairs. There are no pure rolling pairs. So 3 into n minus 1 minus 2j minus h, no higher pair. तो 4 3 is 12 minus 12, it is 0. देखिए सर, देखो. So it is a structure. Means now I am applying. देखो ध्यान से सुनो. If I am applying a force, देखो I am applying given input, but एक भी move नहीं हो रहा सर. देखो it's not moving. I have given the input, but it's not moving. Yes, it is a locked member. Yes, ठीक है सर. यहाँ पे कोई दिक्कत नहीं सर. ये ठीक है सर. Yes, even if I am trying to move this, I have applied. देखो I have applied, but it's not moving. There is no output. So therefore it is a locked member. Locked member. So therefore कोई motion नहीं है. What we do is just I remove this. ठीक है. I remove this and exactly what I do is I'll put it here. देखो एक बार. This is something like this. अब मैं क्या कर रहा हूं सर? देखो. Yes. देखिए. So एक सेकंड देखो. Something like this. See the difference between this and this. The only difference is there is no change in the number of links. There is no change in number of joints. Here number of links are 5. Here also, let's give the number. इसको fix कर देंगे sir. 1, 2, this is 3, this is 4, this is 5. Here also number of links are 5. Let's count the number of joints. 1, 2, 3, 4, 5, 6. Here number of joints. So let me write very clearly. Number of links are 5. Number of joints which are turning pairs are 6. So what should be the degree of freedom, sir? What should be the degree of freedom? देखो 3 into n minus 1. Same ही तो है. It should be 0. Minus 2 times j, no higher pairs. 4 3 is 12, 0. It should be 0. So when it is 0, actually it should not move. एक बार देखना सर. When it is 0, it should not at all move. Like this case. Exactly, it should be like this only, like this. It should not move. देखते हैं सर एक्चुअली हो क्या रहा है. Let's see what is happening physically. Now देखिए, look at sir. Now I'm giving input here. I'm giving input here. Oh my God. Oh my God. Oh my God. When I gave input, I'm getting output. So therefore, with some input, I'm getting output. So if I move it more, it is moving more. Means there is one-to-one correspondence. So input, output. So एक one input से एक output आ रहा है. So degree of freedom should be one. मतलब क्या गलतियां हो रहे हैं सर इसमें. अगेन देर इज इनकंसिस्टेंसी. अगेन कुछ पैराडॉक्स है, अजीब सा लग रहा है. सो लुक एट समथिंग रॉन्ग. सो आई एम द नंबर ऑफ जॉइंट्स आर सेम, द नंबर ऑफ लिंक्स आर सेम, बट द इक्वेशन इज सेम. हियर इट इज द मोबिलिटी इज जीरो. हियर आई मीन द डिग्री ऑफ फ्रीडम हियर इज जीरो, बट हियर देर इज सम मोबिलिटी. So the explanation given to this is, again I am telling you very clearly, geometry of motion, shape, width, कुछ नहीं लिया गया सर इस equation. When I was deriving the equation, simply he took number of links, number of joints, that's it. So here the explanation given is, when this is moving by some amount, this will move exactly by the same amount. If this moves by x, this will also move by x. Therefore, there is a mobility. But यहाँ पे they are not parallel. When they are this distance is not same. That's why it is locked. But here, when this is moving, this is also moving. तो ये move कर रहा है तो exactly same. That's why it is moving. So now the question, this is, देखो, एक point important है. There is one term that is used known as redundant link. What is redundant link? Whether that link is present or not present. If that is not altering the motion, एक बार देख लीजिए सर. Now this is the one. Now let me remove the middle link. Let me remove the middle link. चलो निकाल दिए. Look at now. If I remove the middle link, now देखो, I have removed the middle link. ठीक है सर जी. So after removing the middle link, देखो, I have removed the middle link. What is the motion? Yes, exactly. Whether the middle is there or not. Whether the middle link is there or not. देखो, when there was a middle link, let's keep the middle link. Now see the motion. When there was the middle link and see the motion. देखिए सर, देखो एक बार. Just see. There is a middle link. There is a middle link and see the motion. I am giving input to this. Yes, I am getting output. Now you remove the link. Let me remove the link. Let me remove the link. चलो निकाल दी. So is it not the same, sir? Is it not the same? Exactly, it is the same. Whether you are keeping the middle link, whether you are keeping the middle link or not, I am getting exactly the same motion. Such a link is known as a redundant link. So whether its presence is there or not there, there is no change. It is not altering the motion. That's why इसको redundant बोलना चाहिए सर. तो whenever you encounter such mechanisms, just remove that. Just remove that, and you complete the process by removing that link, because it is redundant. है या नहीं है कोई फर्क नहीं पड़ेगा. So now the question is, sir, is only the middle one redundant link? Now the question is, देखो एक second, is only the middle link redundant link? That is the question. देखो एक बार, look at now, right? No. Out of these three, any one is a redundant. For example, I'll remove this end. ये वाला निकाल दूंगा, blue वाला निकाल दूंगा. I'll remove blue वाला. चलो, I'll remove the blue one. देखो सर, if I remove the blue one, yes, देखो motion, input output exactly same. So why? Because parallel ये कितना मूव हो रहा है? This is also moving by same amount. That's why there is a mobility. But in previous case, this and this were not same. Therefore, it is locked. So therefore, देखो. So out of these three, any one is a what? रिडंडेंट लिंक. तो ये तीन पैरेलल में कोई एक रिडंडेंट लिंक है सर. आइदर आई रिमूव दिस और दिस. देखो, मिडिल वन और लेफ्ट वन और राइट वन, इट विल नॉट अल्टर द क्वालिटी ऑफ द मोशन. देयरफॉर देयर इज अ रिडंडेंट लिंक. दैट्स व्हाई इसका डिग्री ऑफ फ्रीडम क्या करना चाहिए सर? जो मिडिल वाला है या फिर एनी वन लिंक यू रिमूव. सो नाउ इट विल बी समथिंग लाइक दिस. देखो अब क्या होगा सर? 1 2 3, 4. So n is 4. You have removed the redundant one. The joints are also 4. Dekho 1, 2, 3, 4. Yes, now you apply 3 into n minus 1 minus 2j. So therefore, kitna hoga sir? 9 minus 8, it is 1. Yes, this is the explanation, sir. So now, you know, my dear students, I say up हजारों लिंक पैरेलल रखो हजारों लिंक पैरेलल all are parallel the degree of freedom of this is 1 because whatever this distance is moving this also moving so same mobility मिल रहा है but if you keep something like this it will be locked that is the beautiful explanation given so देखो आपको clarity दिख रहा है सर देखो yes even if you keep any number of links all are redundant links so therefore just keep 2 that's all so now the question is sir why do we keep redundant links I taught in inversions. Therefore, parallelogram mechanism में क्या होता है linkage में तो at some times you know there is a chance of losing the shape of parallelogram. That's why to retain the shape at sometimes at some positions it loses that parallelogram shape. इसीलिए वो ऐसे रखते हैं सर so that to retain that shape. There are other reasons also. Now, one more thing, sir. देखो, for example, we have a cam like this. Chalo. Now, let this be the follower. Let this be the follower. Now, let me give input to this and you have output. So, kitne links hai, sir? Fixed is 1, cam is 2, follower is 3. Very good. So, let me write. So, here between 1 and 3 sliding. So, there is one sliding. There is one sliding pair. Between 1 and 2 there is turning. So, therefore, turning is 1. And there is a higher pair, point contact, higher pair is 1. So, apply karo 3 into number of links are 1, 2, 3. 3 into n minus 1 minus 2 sliding is 1 turning is 1 minus higher is okay this is 2 6 minus kitna hoga sir ye 4 minus 1 so this is 1 yes cam and follower mein we have a single degree of freedom because with particular input I get particular jab isko ghuma raha hai so it is getting lifted up but the problem here is look at carefully as this edge is very sharp it may damage the profile of the cam. That's why you may not get smooth motion. After some time, as this is very sharp, the problem may arise. So that's why what we do is, let us keep it something like this. Ab follower ko, let us keep it something like this. Now, yes, अब देखते हैं degree of freedom. Let us say something like this. Let's see the degree of freedom here. चलो. Now, link 1, fixed 1, cam is link 2, this roller is link 3, and this is link 4. Exactly, sir. Exactly. Now, let's calculate the number of degree of freedom. So, ध्यान से सुनो. The number of degrees of freedom. So, number of links are 4. Let's see joints. Sliding कितने हैं sir? There is one sliding between 1 and 4. 1. And turning कितने हैं सर? यहाँ पे एक turning है. This roller is turning about link 4. 3, 4 there is turning pair. 1, 2 there is turning. So total turning are 2. And between 2 and 3 there is a higher pair. That h is equal to 1. Calculate करो. 3 into n minus 1 minus 2 js plus a. ये कितना होगा सर? 1 plus 2. Sliding plus turning minus higher pair is 1. Exactly. तो कितना आ रहा है सर ये? 9 minus 3 to 6 1. कितना होगा 3 to 6 minus 1 is 7 so 2 आ रहा है. Oh my god, क्या में 2 degree of freedom? कुछ गड़बड़ है सर. It should be 1. Just I have changed the shape. So I am getting. So what explanation is given? ध्यान से सुनो. There is one term known as redundant degree of freedom. What is redundant degree of freedom? Without disturbing input and output. If a link or group of links can be rotated freely without disturbing input, output को बिना disturb किए अगर कोई motion मिल रहा है, that is known as redundant degree of freedom. Now you just say, this is the input, this is the output. Input output को बिना disturb किए, this roller we can easily rotate about this. Therefore, एक फर्जी और unnecessary degree of freedom is available. Therefore, out of these two, remove this redundant. So therefore, it is 1. तो अदरवाइज आप एक काम करो सर. डू यू वांट द रिलेटिव मोशन बिटवीन दिस 2 and 3 सॉरी 3 and 4? नो. सो व्हाट यू डू इज यू जस्ट वेल्ड दिस या फिर इसका शेप ऐसा कर सकते हैं सर. देखो सिंपली यू कैन मेक द शेप ऑफ दिस लाइक दिस सिंपली. सो नाउ 3 4 विल बिकम 1 लिंक. 3 4 विल बिकम 1 लिंक. तो क्या होगा सर? इफ 3 इट्स समथिंग लाइक दिस. देखो एक बार. देयरफॉर इट इज समथिंग लाइक दिस. यस Please don't think that it is like this. Spring bhi hai, because spring is not taken as the link, because the purpose of spring is either to absorb energy or store energy. So koi relative motion में काम नहीं आएगा. Link is providing the relative motion. I taught very clearly. Now fixed link is 1. This is link 2. ये पूरा एक ही link है sir. This is completely link 3. ये पूरा. अब कैलकुलेट करो. Number of links are 3 and joints. देखो, एक टर्निंग एक स्लाइडिंग. सो टर्निंग एंड स्लाइडिंग इज 1 एंड हायर पेयर, ये हायर पेयर एक है, एक स्लाइडिंग है, यहां पे एक टर्निंग है. अप्लाई करो. 3 इंटू n माइनस 1 माइनस 2, जे एस इज 1, जे टर्निंग इज 1 माइनस हायर इज 1. तो कितना आ रहा है सर? 6 माइनस 2 4 5 so 1 exactly. So why I say you should be very very cautious sir, especially when you come across such things. You should be very very cautious. So therefore be careful sir. Iska degree of freedom 1 ही होता है sir. Be careful, be careful. And one more thing, let me tell you redundant constraint. For example, there is a circle. Now a wheel is rolling on the ground, let us say. You know it is a higher pair. In higher pair, one, अगर प्लेनार मोशन की बात कर रहे हैं, इन प्लेनार मोशन देयर आर 3 डिग्री ऑफ फ्रीडम फॉर एवरी लिंक. व्हाट इज दैट? एक्स ट्रांसलेशन, वाई ट्रांसलेशन एंड रोटेशन अबाउट z एक्सिस इन xy प्लेन. ठीक है सर. बट यहां पे whenever it is paired, let this be link 1, let this be link 2. Whenever it is paired, certain degrees of freedom are arrested. यहाँ पे 1 degree of freedom is arrested. Which one is arrested? There will not be any motion along the common normal. This is the common tangent. This is the common normal. Along the common normal, the motion is arrested. What is the reason for that? Suppose this link 2 moves in this direction along the common normal. Either it breaks, it damages, if it moves in this direction, or if it moves in along the common normal upwards, the contact is broken. Pair means there should always be contact. So if it moves upwards, contact is broken. If it moves downwards, it will damage. Therefore, always remember in higher pair, the motion along the common normal is arrested. So 1 degree of freedom arrest हो गया. बचा क्या है सर? It can move in this direction, it can rotate. ठीक है सर. Now there is one higher pair. ठीक है सर. Now what I do is I will put some maybe a wall or something like this. Now should I count the degree of freedom 1 or 2? Sorry, higher pairs 1 or 2. देखो, you may be thinking this is one higher pair, this is one higher pair, but the answer is wrong. The reason is this additional constraint is not at all resulting in any change in the motion. Originally it was capable of rotating. Now even after putting, it can rotate. Originally it was in a position to translate. Now also it is translating. So therefore this constraint is unnecessary. इसको बोलते हैं redundant constraint. So you should not take 2, you should take only 1. Why redundant constraints are used? Maybe to strengthen. ठीक है ना? Therefore it is only, understand carefully. Suppose now we have something like this. Suppose I put constraint like this. देखो, now how many degrees higher pairs are we supposed to count? Here I should count 2 higher pairs, because it is this constraint is arresting x motion and this is arresting this motion. So only it can rotate. So therefore here it is 2 pairs. So you should be very very cautious. Quality of motion is very important. So all these things I have discussed beautifully with all models. देखो, these are with models I explain in my class. So how beautifully I had explained with this model in class. ये model के साथ how the degree of freedom is 1. Beautifully I had explained how the degree of freedom is 1 in my class. बहुत सारे models से हमने क्लास में डिस्कस किए सर. And we have discussed this also. देखो, ये वाला भी डिस्कस किया. देखो एक बार in our class. How the turning and इसमें sliding कैसा होता है, beautifully we have studied. So I'll be coming up with many more such like series with models. So thank you, and if possible please suggest us. So what are we supposed to do? Okay, thank you, goodbye.